Good afternoon, Professor. Today I'll be doing number 1, part A, because my birthday is October. 1 plus 0 is 1. How many... First, let us consider a sled. Mass M is being pulled by a constant, so that's F, so P. Horizontal force along a rough horizontal surface, so there's a force of friction. There is a normal force, and there is the force of gravity, or mass. And how many forces are acting along the sled? There are 4 forces. For part B, it's asking the work done on the sled by the force of gravity. The answer is 0, because there is no movement in the y direction. For part C, the work done on the sled by the normal force is once again 0, because there is no movement in the y direction. For part D, it's asking the work done on the sled by the pulling force is going to be positive, because the sled is speeding up. For part E, the work done on the sled by the force of friction is negative, because friction works against the movement direction. For part F, the work done on the sled is positive, because once again, the force of gravity cancels out with the force of the normal force, and we already discussed that the pulling force is greater than the frictional force, so the work done is positive total. For part G, the kinetic energy of the sled increases, and the key word there is speeding up. For part H, it is asking, find the net force acting on the sled. So, for part H, we know that F net equals MA, and A can be equal to V2 over V1 over T, and V average is equal to V1 plus V2 over 2. So from that we can get A equals V2 squared minus V1 squared all over 2S, because S is average velocity times time. So F, since A is equal to V squared, or this, then and A is being multiplied by M, the final answer, F net, is equal to mv2 squared minus mv1 squared all over 2S. For part I, it's asking the net work done on the sled, and we know that work equals Fs cosine theta, and cosine theta right now is equal to 1, so it's just going to be work equals force net times S. For part J, work net equals K2 minus K1, and we know that K equals 1/2 mv squared. So we know that the work net will be 1/2 mv2 squared minus 1/2 mv1 squared. And finally, part K, we have the car from mass accelerates from the speed v1 to v2 while going up a slope that makes a angle. The coefficient of static friction is mu, and acceleration due to gravity is g. Find the total work done on the car by external forces. Okay. Work equals K equals 1/2 mv squared, and work equals K2 minus K1. So we just use that again, where it's negative this time. Mass v1 squared plus m v2 squared, and that's all over 1/2. This is Andrew, and thank you for your time.